In this lesson, we're going to examine a third algebraic technique. So we talked about comparison, where we make the two equations equal. We talked about substitution, where we put one equation into the other. Here we're going to talk about a third one. We call this elimination. We use this method when the equations are not rearranged so that they have a letter by itself. You don't have y equals or x equals. And if you were to try and do that, you create fractions or decimals. So generally, all of our equations are going to be in some sort of order, like 2x plus 3y equals, I don't know, 7. Okay, so you'd end up with decimals if you're trying to get the x by itself, or fractions if you're trying to get the y by itself. The objective in this method is to eliminate a variable, get rid of that variable, the x or the y. And we do that by adding or subtracting the two equations together. We know to either add or subtract according to which variables have the same values. So for instance, if I saw this, in this equation, my x's have the same coefficients. They both have the number 2 out front. And in front of those number 2's are signs. We don't see them, but we know there's plus signs. Because these 2's are the same, and they have the same sign, our rule is going to be same sign, subtract. And we're going to subtract straight down. So 2x minus 2x would be 0x. And 0x really has no meaning, so we ignore it. We eliminate it. It would be gone. Okay, the 3y minus 1y would give us 2y's, and 7 minus 4 would give us 3. And we'd have just this little bit to solve. So we're going to try some. Okay, here's my expression. It's kind of suspiciously familiar. Okay, what do we got? I've got 2x and 2x. They both have the same value. In front of that, we have two plus signs. We don't see them, but we know they're there. They are the same sign, so we're going to subtract. Big line underneath. And then we're going straight down. So 2x minus 2x gives us no x's. I'm not even going to write the letter x in there. 4y minus 3y gives us y, or if you want to, 1y. And 9 minus 4 gives us 5. And what do you know? We've got y already. Y is 5. Once I know what one of my letters is, I have to go back and find the other letter, because a point of intersection is made up of an x and a y. And here's the unfortunate part of the elimination method. It takes longer to find the second letter than the first one. So let's pick an equation. I'm going to pick the bottom one. I just picked it because it has smaller numbers. And I know something. I know y is 5. So I can replace the y with 5. I want to get rid of my brackets, make it a little bit easier to work with. And I'm going to solve this. I'm going to put letters on one side and numbers on the other. So I'm going to bring the 15 over here. 4 minus 15 is negative 11. I divide that out, and it comes out to a decimal, but it's a nice decimal. 5.5 is totally fine as a decimal. It's a 0.5. Nothing wrong with that. Okay. POI, my x value was negative 5.5. My y value, way back up here, we figured out that y was positive 5. And I've solved it. It's done. That's my answer. Okay, that's how elimination works. So you guys try the next one. Okay, we're looking for numbers that are the same. Well, the x's aren't, but the y's are. They both have 2's. So I check out the signs. My signs here are not the same. They're different. So if the rule is same sign subtract, and I have different signs, I'm going to have to add. Again, we're going straight down. So 3x plus 1x makes 4x. 2 plus negative 2. Just to point out, 2 plus negative 2 is like saying 2 minus 2, which is 0. The y's will eliminate each other. And when we do 5 plus negative 1, again, that's like saying 5 minus 1, we'll get the number 4. All right, divide that out, and x is 1. We got x. Let's go back and find y. So I'm going to use the bottom equation again, but I'm going to put x in as 1. So I get 1 minus 2y. It's negative 1. I want letters on one side and numbers on the other. So I bring the 1 over here. I'll get negative 2 on the right. And if I divide that out, I get y is 1. So my POI, x first, make sure x goes first. So in this case, they're the same numbers, so it doesn't matter. But make sure x and y. Done. 1, 1. There's my solution. And if you wanted to, you could check that. how could I check that? Well, we used this equation to solve for y. But if I look at the other equation and I think about that, 3x plus 2y is 5, and I know x is 1, and I know y is 1, well, if they're the right answers, then this better come out to 5. And 3 plus 2, yeah, it's 5. Oh, I got the right answer. So I can check it by using the other equation, just like we did with substitution or comparison. Okay, let's try some other things. You guys can try C, pause the video, give it a try yourself. So take a look at this. I'm looking for numbers that are the same. I see a 3 and a negative 3. The numbers are the same. The signs are not. My rule is same sign subtract, but here I have opposite signs, so I'm going to have to add again. Negative 3 plus 3 is 0. 2 plus negative 6. 2 plus negative 6. That gives me negative 4 y's. 5 plus negative 1. That gives me 4. Divide it out, and y is negative 1. Okay, I'm going to pick one of my equations. I'm going to pick the bottom one. I'm going to replace the y. Y is negative 1. I'm going to get rid of my brackets. I'm going to solve this. So numbers on one side and letters on the other. I'm going to bring the 6 over to the other side, right here. That gives me negative 7. Ooh, that doesn't divide nicely this time. Not even a nice decimal. So I'm going to leave it as a fraction. Negative 7/3. There's nothing wrong with fractions. I don't need it to do anything. It's just part of my answer. So my POI is negative 7/3 for x. And y, from way back up top, was negative 1. Make sure again, in the right order, okay? X, then y. Alright, let's try D. Elimination. I'm looking for things that are the same. My x's have different numbers. My y's have different numbers. So I can't eliminate right off the bat. What I need to do here, if no coefficients are equal, is I need to change one of my equations. I need to multiply by some constant to create equal numbers. And we know we can do that because we talked about the idea of infinite number of solutions. When lines are on top of one another, right on top of themselves, they have the same equations, but they're just different versions of each other. So that's what I need to create here, a different version that will make my life easier. So for instance, if I times this whole thing by 2, the whole thing, well, the top one would still be the same. So I'd have 2x plus 5y is 4, but the bottom one would now become negative 2x, positive 6y, and 18. And now I can do elimination because I have the same value. Okay, 2 2's. I look out front and I see I got one minus sign and one plus sign. Those are opposite signs, so I can add. 2 plus negative 2, it's gone. 5y plus 6y makes 11y, and 4 plus 18 makes 22. If I divide that out, I get y is 2. I solved that part by creating an equation that was helpful for myself. This is not a new line. It's just a different version of that line. Hey, once we do that, the process stays the same. We know y, let's go back and find x. So I'm going to pick an equation. I use the top one this time. 2x plus 5y is 4. I just like that because it's all positives. I could have picked a different one. I know that y is 2. So I'm going to replace it with 2. Get rid of my brackets. And get numbers on one side, letters on the other. So we're going to bring the 10 over here. So it becomes subtracting. That's negative 6. And if I divide that out, I get negative 3. So my POI, with the x, which was negative 3, and the y, which was 2. Make sure at the end you write down POIs for me. You did all the math. Give me the right answer, right? Okay, let's look at the next problem. You guys can try this one. So pause it, give it a try. Looking for things that are the same. 3 and a 2 are different, a 2 and a 4 are different. How can I make them the same? Well, if I times this by 2, I'll end up with 6x, 4y, and 2. That's helpful because my y is matched now. So I'm going to ignore this question right now, or that equation, and use the bottom two. In the bottom two, the 4's have the same number and the same sign. So I'm going to subtract. That's going to give me negative 4x. 4y cancels with the 4y. And negative 4 over here. Divide it out and I get x is 1. Once I know x, I can go back and get y. I take one of my equations and let's replace. So 2 times 1 plus 4y is negative 2. Get rid of our brackets. Rearrange it. So bring the 2 over to the right side there. So I'll get 4y is negative 4, which means y is negative 1. Done. POI, x first, 1, y second, negative 1. All right, try this last one here, I think it is. What's the same? 3 and 2 are not the same. Nope. 2 and 5 are not the same. Okay, I got to multiply then. What do I need to multiply? Well, there's not much you can really multiply 2 by to make into a 3, or 2 by to make into a 5, easily. So why not multiply both of them? Let's take the first one and multiply it by 2. And the second one multiply it by 3. That way I end up with 6x and 6x, which will make two things that are the same. And that's our objective, right? To make letters have the same coefficients, the numbers out front. If we can do that, we can do elimination. So it's easier if you wanted to multiply one equation, but it's totally fine to be able to multiply both equations. Here, x's have the same coefficients and they have the same signs, they're both plus signs. We're going to subtract 6x minus 6x, I have no x's. Negative 4 minus 15 will give us negative 19y's. Here's the tricky one, negative 2 minus negative 21. Well, that's like saying plus 21, which is like saying 19. So I got 19 on the right. Divide it out, and I got y is negative 1. Now I have to go back and get x. I'm going to go back to one of the easier equations. I can go back to one of the original equations. I'm going to take 2x plus 5y equals negative 7 and use that. You can use any of the 4 equations, the 2 originals or the 2 new ones, to solve for the second variable. So we know y is negative 1. So 5 times negative 1 is negative 7. I want to rearrange this, so bring the 5 to the right side, make it a plus sign. So 2x is negative 2, and x is negative 1. Therefore, our POI, x is negative 1, and y is also negative 1. And you've solved it. Okay, so the key there at the end, make sure that as soon as they're the same, you can multiply both equations if you need to. Try and do less work if you can, but you can do more if you need to. Okay, last thing, word problem. So our objective here is we want to keep going back to how do I apply this stuff? How do I apply this stuff? So we're going to look at a mixture problem. 2 different kinds of coffee beans were blended. Individually, they cost $2.30 a kilogram and $3.20 a kilogram. How much of each kind was used if 200 kilograms costs $3 per kilogram? So what do we need for word problems? We need let statements. What do we not know? We don't know how much of each kind was used. So that would be the amount, in this case, kilograms of type 1. And y would be kilograms of type 2. The things we're being asked to find should be our let statements, the things we don't know. That's step 1. Step 2, we need equations. We know we're making 200 kilograms of this stuff. So x plus y is 200. We also know that each of the kilograms we use has a value. The first one costs $2.30 for every kilogram. So 2.30 for every kilogram. Plus, the second one costs $3.20 for every kilogram. And the whole thing costs $3 for every kilogram. But we know how many kilograms there are. So our total cost will be 3 for every kilogram, or in other words, $600. That's where that comes from. Now this looks like a perfect elimination question for me. I've got XY number. But right now, my X's don't match. My Y's don't match. But I can really easily fix that by timesing this equation by 2.30. That will give us 2.30x plus 2.30y and 460 as the number. And now I've got an elimination question. Okay. Looking at the x's, they have the same value and the same sign, so we're going to subtract. The x's will cancel. Over here, we'll get 0.9y and 140. This one's a little bit messy. Y is going to be 140 divided by 0.9, which comes out to, a really messy number, 155.56. It's messy. Nothing you can do about that. It's a word problem, so I have to go to decimals in this case. Once I know y, I have to go back and figure out x. I have a really nice equation for x. This original one, x plus y makes 200. So if x plus y is 200, and yet we know that y is 155.56, we can figure out x really quickly. I'm just going to do a quick little subtraction. You don't even really need to show me this piece, but we'll just do it anyway. Okay, there's our two variables. What do we need at the end? Therefore. All right, to make the mixture, you need 44.44 kilograms of type 1 and 155.56 kilograms of type 2. Okay, and there's an elimination question. Most mixture situations are elimination because you get x and then the y, then the number. So homework today from the book. Okay, try some of the questions. Okay, we want to be pretty good at using elimination, and we're looking for your constant that's the same number. Check out the sign in front of it. Same sign, subtract. If you're stuck, come see me, and we'll keep working on some algebra stuff.